Our video today is going to cover the Pythagorean Theorem. The gentleman behind this was named Pythagoras. He is often referred to as the first pure mathematician. He was born on the island of Samos. He was very well educated. He played musical instruments, recited poetry. His interests were mathematics, philosophy, astronomy, and music. So the Pythagorean Theorem is kind of one of the most recognizable theorems in math. It's the sum of the squares of two legs of a right triangle, and those equal the square of the hypotenuse. So you work with a formula that is a squared plus b squared equals c squared. So how it works is actually pretty simple. We are going to put in the two legs for 6 and 9, which are the a and b. We're looking for c, which is our hypotenuse. So we're going to put in 6, square it, 9, square it. That all equals c squared. So when you do this, we're going to take and get 36 plus 81 equals c squared. When we add those two together, we get 117 equaling that c squared. The final step is we're going to take the square root, which gets rid of the power, which leaves us with c, which in this case our answer we're just going to leave as 117. You could put it into decimal form, or you could figure out a factoring or simplification of it if you'd like. So for looking at this one, we're given c, we're looking for a, so we'll keep a with the squared. Our b is given as 8, and our c is given as 10. So a squared plus 64 equals 100. If we subtract 64 from both sides, which will take care of getting rid of the 64 on the left, that will leave us with 36. And again, our last step here is going to be our square root, and that would be 6. And that would be what we would put in for our side A. So here we're again looking for A. So we'll put in a squared, our b is 9 squared, our c is again 10 squared. So our a squared plus 81 equals 100. We're going to subtract 81 from both sides. Leave us with a squared equals 19. Again, we take this and square it, which gives us a equals the square root of 19. We can't simplify it, so if we're asked to put it as a decimal, we can use a calculator and we would round it to the nearest tenth to come up with 4.3. Some of the questions that we're going to run into give us some special cases. One is a square, and if we're asked to find the diagonal of that square, this turns it into basically a right triangle with the a and the b sides as going to be the same. C is our hypotenuse, which is the diagonal of the square. What that does is it sets up a kind of a special situation with triangles, and for this case it's actually a pattern that happens. So we're going to go through each one of the patterns of this. So in the first one, we're going to take 1 and square it, which gives us 1. Add those up, gives us 2 equals c squared. We take that and get rid of the c squared. Our c is going to be the square root of 2. If we go to the second example, we're going to take 2, square it, add that to 2 squared. Again, we're equaling c. So we've got 4 plus 4 equals c squared, which gives us 8 equals c squared, which we take again the square root, which gets rid of the square. We're left with c equals the square root of 8, but we can simplify that through what we've done in the past, which would end up giving us 2 times the square root of 2 for our side. Now, we can also do this with 3. So we'd have 3 squared plus 3 squared equals c squared, which gives us 9 plus 9 equals c squared, which gives us 18 equals c squared, which again we would have the square root of 18, because we take the square root of it, get rid of that, that equals our c. But again, if we simplify that down, what we're going to look for is we're going to get 3 times the square root of 2 for our answer. So the pattern is the coefficient that you see in front really is what the length of the side is. This is our hypotenuse, so this tells you the side. If you're looking for the hypotenuse, you just put the square root of 2 at the end of it. In this case, we have something a little bit different. We're going to solve for b here. So we're going to say 9 squared plus b squared equals, now we have the square root of 98, and that is all squared. So we end up with 81 here plus b squared equals, and again, these are inverses of each other, so the power and the root go away, so we're just left with 98. Now we go ahead and solve it the way we normally do, get rid of the 81 to both sides. That leaves us with b squared equals 17. Take the square root of that, and our answer would be the square root of 17. And again, we could put that into a decimal form as well, depending on what the directions of the problem state. So a practical part of using the Pythagorean theorem would be to calculate the distance of a road that maybe they want to redo. In our case, the city of West Wendover wants to redo a road due to some damage. The road that we're talking about is this one right here. So we're going to redo that part of the road, and we're going to be charged a certain amount per foot. So we have to know the distances here, the distances here, and that will give us the idea of how to solve for this problem. So now we've been given our diagram. We've been given it in miles for each of the section of road that we're looking at. So we've got our 4 miles, our 3 miles here, and this is the site that we're going to be solving for. We're going to deal with it in miles, but eventually we have to turn it into feet. So this is a conversion that you'll need for this section and for whenever you use any conversions that you need. So it's pretty straightforward in this first step. We're going to take our two numbers, our 4 and our 3. We're going to square it to give us this, which will give us 25c squared. We're going to take the square root of that. So that finds us out that we have a distance here in the part that we're replacing at 5 miles. Well, because our problem says that we're going to be charged per linear foot, we really cannot use this 5 miles. So what we're going to do is we're going to convert it with the miles to feet, and that is where this second step comes into. So our second step is actually a conversion problem of taking our 5 miles and multiplying it by the conversion of 5,280 feet to give us our feet that we need to use for this problem. The last step of this problem is to figure out how much it's actually going to cost us. Being that we've taken and found our miles, we've converted it to feet, now we know that we're getting charged $80 per linear foot. Each of those feet is $80, so if we have a large number, obviously we're going to multiply it. So we're going to take our 26,400 times our 80, and that's going to give us a value of $2,122,000 that will replace, or the cost to replace, this road in town. So a couple keys to this, pretty simple. It is pretty well straightforward. First thing is identify what side you're going to be solving for. 2, make sure that you start off with this formula when you start your problems. You're going to use a conversion at times depending on what you're being asked to use. In our case, we're going to use miles to feet. But the bottom line is you want to make sure you're solving it completely, which means you get your X or your C or your A or your B completely by itself. One last item I'd like you to do for this video is to use your phone or your parents' and go around the town, find something somewhere around town that you could use the Pythagorean Theorem to solve for one of the sides. It must be an original picture. When you get that picture, you're going to email it to me with a description of where you took it, so I can maybe go out and look at it and see what you saw. And my email is listed here. Again, you should already have that. And you need to have this emailed to me by Wednesday at the end of the day. So please go out, enjoy, look for something that looks interesting, and see how that works for you. So hopefully you'll take all the information from this section, use your notes, use the conversions. Remember to go out and do your problem and send it to me by Wednesday through the email and a description of where you took the picture at, and have some fun with that one.